Um, Hi, folks. This is gonna be the session on a that's very large, very short introduction to the Unix command line or Bash, which is a thing that is not only very useful for this workshop as you folks continue throughout the week, but also basically your everyday scientific life. As Lex mentioned before, my name is Per, and I'm also at the Neural Data Science Lab at NEMNI McGill, working as a postdoctoral researcher with Jean-Baptiste Pauline. And a few things before we actually going to start with the content. So most of what you will see within this lecture was actually prepared by Ross McCullough for the annual Montreal Brainiac School, which happens either in May or August, depending on a lot of factors. And if you have not heard of this before, make sure to check it out under the link I posted here, which is, so just maybe a few sentences on that. It's an amazing fall-week program, which is organized by 4 universities here in Montreal, which is McGill, Concordia, Université Montréal, and Polytechnique. And it's basically a very nice summer school where in the first week you get like a full-on neuro data science programming crash course, and then as you continue throughout the weeks, work on different aspects of scientific workflows. That is making it more reproducible, talking about data analysis or visualizations. You can also work on your own project. So it's a fantastic opportunity to really dive into these aspects. The content itself here is based on the Software Carpentry's introduction to Shell, which I also posted a link here if you want to check that out further. We are going to not really work with, but explore a bit an example data set. And I posted the link here, and it's also in the Slack channel. So if you go in Slack channel group 1 and then check the pinned items, I posted a link there. So if you just click on that link, it would download a very small zip file. Could you please unzip it and place it on your desktop? And as I wrote here, I will try to post this link as well into the Zoom thing, but as yesterday, I don't see the classic communication thing. Let me see if it works today. No, not really. So if someone sees the classic like chat function, because I don't see it in this current mode, could you please put the link also there?
Sorry, you don't see the chat?
No, I don't see the chat. It's like one of these Zoom perks.
Oh, that's weird.
So there it is. Oh, it was hidden over there. I have it.
Okay. So is that the link that you sent out, same as yesterday?
Yeah, I now have the.
Yeah, okay. So all of that is available, is pinned to the general chat. It's also linked in the group 1 channel on Slack. And okay, Per also found it. Okay.
Yeah. Okay, so for everyone else interested in that, I don't know if you can see it now. It's in the more, and then it's hidden over here, the chat thing, and not anymore like the classic panel here. Okay. These online things, eh? Okay, assuming that at least everyone has the link now, we can continue. So actually asking and starting with what is the shell? The shell in itself is a command line interface, or short CLI, to your computer. So it's a way for you to communicate with your computer, asking your computer to do things, asking where things are and whatnot. And this is basically in very large contrast to the graphical user interface, or GUIs, that you normally use. So if you use like any of the programs on your computer, for example, mine you see here, these are all a graphic user interface. So if you click on them, they pop up and you can interact with them and your computer basically with this graphic user interface where you click on buttons and do things. The shell is, however, also a scripting language that can be used to automate repetitive tasks. So just think about if you have to, for whatever reason, rename 100 files. You could also do that with your graphic user interface, click on each file and then change that. But as you might have experienced already in your work life, this is very cumbersome, takes a long time, and it's very prone to errors, because if you do that 100 times, and maybe listen to an audiobook or binge watch Netflix, then problems will appear and you don't know when they exactly happened and how to fix them. But what's this bash shell? Because we used different things before, right? We said shell, bash shell. So it's actually one of many available shells where you have for example, the SH shell, which is the Bourne shell, the TSH, that's the Korn shell. We also have CSH, C shell, TCSH, 10X C shell, and we have bash, the Bourne again shell. And we will focus on this one. You might now ask, why so many? Why are there so many different shells floating around? Well, they all have very different strengths and weaknesses, and you will see many of them throughout much of neural networking software too, and different of them. So, for example, SH is very frequently used in the FSL software package, whereas CSH and TCSH is very commonly used in FreeSurfer and Afni. So if you work with these tools before, you encounter most likely one of these shells. So as said before, we're going to focus on the bash shell. And the reason for that is that it's perhaps the most common shell that is available in almost every operating system. It's the default shell on most Linux systems. It's the default shell in the Windows subsystem for Linux, if you use that, short WSL. And it was actually the default shell on macOS systems prior to 10.14 macOS. Starting with macOS Catalina, there were a lot of very, very famous problems by now. However, one of them that's usually not very talked much about is that the CSH shell is now the default based on licensing reasons. However, you can still use bash. It's still there if you are running Mac OS Catalina at the moment. Okay, so we outlined this a bit before and addressed it. Why use the shell at all? Isn't the URI good, just not good enough? Well, graphic user interfaces are good and you can do a lot of things with them. But the shell in itself is very powerful because you can actually have sequences of different commands that can be strung together to quickly and reproducibly make very powerful pipelines, which might be harder using a graphic user interface. We have to do things step by step. Also, you need to know how to use these things, the shell, to access remote machines and high-performance computing environments, for example, Compute Canada. So while it's possible to run graphical user interfaces on high-performance computing environments and also remote machines, this is usually not recommended for various reasons. One of them is very obviously that if you do these things, they have a very large delay because everything needs to be rendered, put back and forth, and it's just not a nice way of working with those things. And some aspects are just not accessible and usable with graphical user interfaces, and you need to actually do that via the bash. We also already said this before, we will not be able to cover all or even most aspects of the shell because it's just too much out there and there's too many things you can do with the shell. But we will get through some basics that you can build on going forward within this workshop, but also later on. So now actually starting with the bash shell, we're going to now open your terminal. For the Windows people, if you have Windows Subsystem for Linux installed, WSL, please open that one, the Ubuntu application. For Mac and Linux people, just open the terminal. For Windows folks that don't have the Windows Subsystem Linux, please use git bash. This should be part of the Anaconda environment, the Anaconda program you installed. To access this, I was told you should please go to the search function in Windows, type git bash, and then it should pop up. You click on it, and then it should open it. So I'm gonna just fire up a terminal on my end. This is how it looks. I'm gonna make it a bit bigger. And just give it a minute or so for everyone to get there. If you have any problem finding your terminal, opening it up, or what have you, please let us know. Okay, for the sake of time, we going to continue now. Oh, sorry, it's my bad. So I'm just going to go back to my presentation. And when you open the shell, you should be presented with a thing called the prompt, indicating that the shell is ready for when waiting for input. And this is this $sign here. And the shell typically uses this $sign as the prompt, but depending on your operating system or installation, whatever you use, there might be different symbols. And what it basically is, what we see here when we see the prompt is that the terminal, the bash, our computer is ready for us to give any sort of instructions, basically telling us, I'm here, just let me know what you want to do. An important note here, when typing comments, either in this lesson or from any other source or what you see on resolutions and things like Overflow, what people tell you, please do not type the prompt. Do not type and add this $sign when you put in things. Only the comment that follows it. So it's a very nice copy-paste error that happens quite often. So the question now is, are you actually using bash? So we can check that, and we can, using the following comment, to determine what shell are you using. And at this point, I would outline a very important thing for this lesson. While you're going to use the terminal, however it looks like on your machine, and type things there, for example, echo shell, and run it while pressing enter. You see your stuff there. What I will do for my part here is actually run those comments within my presentation, because putting my presentation and the terminal next to one another is just not very nice to look at, and it's easy to get confused also on my end, going back and forth all the time. So I will run comments here in my presentation, because I can run the bash from within this presentation. It's a very nice feature of Jupyter Notebooks, so that you don't have to go back and forth all the time. But whatever you see written here in my shell or my command line here, please just type that in your terminal and then run it. So if it doesn't say something like what you've seen on my end here, that is /bin/bash, then simply type bash and press enter and try running the command again. So just type bash. I'm going to do that here. Press enter. And if you have bash available on your machine and you weren't in the bash shell before, you should now be in the bash shell. There might be other ways on getting the bash shell to run, depending yet again on your operating system and installation. And if there are any problems, please let us know. A note on the echo command, it does actually exactly what its name implies. That is, it simply echoes whatever we provided to the screen. So it's like print in Python or R, or display in MATLAB, or print4 in C, or any other comparable thing in whatever programming language you have. What's with the $sign shell? Well, things prefixed with a $sign in bash are mostly what is called environmental variables. And as you might know by now, all programming languages have variables. Bash is or the shell is no exception to that. And you can assign variables in bash, but when you want to reference them, for example, in a script or a workflow, you need to add the $sign prefix to them. And we dig into this a bit more later, but by default, our shell comes with some preset variables. And as you've seen before, the $sign shell is just one of them. So let's try our first, or actually second, comment in bash. And this comment we're going to try here lists the contents of our current directory. So sorry for that. We just type ls and then press enter and run it. And what you see is all the files that are currently in your directory, in the place on your computer, your machine where you are. What happens if you make a typo in bash? or if the program we want is installed in your computer. The question is, will the computer magically understand what we're trying to do, what it's happening? Just simply try it. We type ks, and this command is not existing. And the bash basically tells us that bash is trying to run the command ks, but this command is not found. So you will get a more readily helpful error message depending on the program and the things you want to run. Talking briefly about the cons of the command line interface. Unfortunately, you need to know the names of the commands you want to run because there's no graphical user interface. You cannot basically search for them while just looking at this program. But you need to remember like at least a few of them, or remember how to get more information and find out how certain programs are called. Sometimes comments are not immediately obvious. So for example, why is it ls over, for example, list contents? But the more you start and actually doing with the bash and shell, the easier it will get. Because you will use comments over and over again, and there's like a solid base stock on things you will like do basically every day. Some key points for this very overview introduction to what actually shell is. It's a program whose primary purpose is to accept comments and to run programs. The shell's main advantages are its high action to keystroke ratio. So with only a very short comment, a very few lines of code, you can achieve a lot of things incredibly fast and reliable, because it supports for automating repetitive tasks and its capacity also to access remote machines. Like I said before, for example, Compute Canada. The shell's main disadvantages are its primarily textual nature and how cryptic its comments and operations can be. So as with any other programming related thing, the classic thing you got to say here is it's a steep learning curve. Now talking a bit about navigating files and directories. So the file system is the part of your operating system for managing files and directories. And there are a lot of commands to create, inspect, rename, and delete files and directories. And indeed, these are perhaps the most common commands you will be using in the shell. So where are we right now? I don't mean in terms of like a geographically or point in your life or whatever, but on your machine, on your computer. When you open a terminal, you are placed somewhere in the file system. At any point in time while using the shell, you will always be in exactly one place. So it's not like quantum mechanics or theory. It is not, you can be in different places at the same time when using the shell. It's always going to be one place and exactly only that place. So when you run comments, for example, to read, write, and operate on files, this is where those comments will be applied to if you don't specify it further. So it's important to know where you are in your shell. And you can find out your current working directory very easy with the following command. It's pwd, and if you run that, the output will be the current place where you are in your file system. And for me, that's in /user/ my username on my machine. I'm running a Mac OS, so this is the classic path you would see here. For Linux-based users, you will see something like /home/ your username. For Windows users, it depends again on your software. You might see something like what I see here right now, or maybe something different. And we're going to look into that in the next slide, I think. So as it might occur to you already, many bash commands are acronyms or abbreviations because it's actually there to try and help you to remember them. So for example, the command above, pwd, is an acronym for print working directory. And now, as said before, we're going to talk about the whole OS dependent paths. So the printed directory may look different depending on your operating system. So anything Unix-based, it is Linux, Mac, and also if you use the Windows subsystem for Linux, it should look something like what I've seen on my end here. If you run Windows without the Windows subsystem for Linux, you might see something like this here. It's a capital C colon, / users, / whatever your account name is in your machine. Through this lecture, and I think also depending on where you look for help online, there's a certain notion to this, and we are going to use the /users / username notion for the REST example. So if we run something on this, but what you see on your end is something like this here with the capital C colon, just please adapt these paths in the examples so that it works on your machine. So we're now going to have a look at an example file system. And this is our example file system right here. At the top, what you see, this one here, this is what it's called the root directory, which holds the entire file system, everything that is on your machine. And inside there are several directories. You got bin, which contains some built-in programs ready to run. You got data, where, for example, you store some scansless data files. You got users, where personal user directories are. And you got a TMP or temp, which is for temporary storage of files. Our current working directory, what we've seen before, was inside users. So an important point on the / character here, if it refers to two things, or it can, basically has two functions here. If it's on itself, it refers to the root directory when it appears at the start of a path, so the earliest path starting point on your machine. However, it's also used as a separator between directories when it appears inside a path. So as we've seen before, if we go from root to users to some username, the differentiation in the paths is marked by a /. So for example, if we are in users, this directory contains different folders for different users on your computer. So if you are on a laptop, most likely will just be one user, which is your account. However, if you are on shared file systems, Compute Canada, or if your lab has its own little server system, users will contain all these different people and their usernames and their respective data, scripts, what have you in them. So they can have multiple. When you open a terminal, it usually defaults to your home directory. For example, as you've seen, but for me, /user / my username, you can change that behavior, but by default, it's always going to be your home directory. So let's remind ourselves how to see where we are and figure out what's in there. We can use pwd, print working directory, to see where we are, which is in our home directory. And then we can use ls to find out what's in there. Your results, again, to make it clear, are likely different in this, because if you would see the same results I see here on my end, would mean that most likely you are on my computer, which would be not cool. So don't worry if you see something different here, right? It should also be, it's always dependent on your operating system and your machine, at least the comments we run so far. ls, as we saw before, prints the contents of our working directory, and you can actually make it tell us a bit more information about our directory by providing what's called an option to the ls command. So if you type ls space -F and run that, what you see is some things change. Namely, the F option adds a helpful marker to the end of each of the listed contents in your working directory where you are right now, where a / indicates this is a directory, and @ indicates this is a link, And star indicates that this is an executable, something you can run. Your contents may also be color-coded depending on your default options, how we set these things up. So for example, here, what you see is that my directories and folders here, those are color-coded. They have a different color than files. Also note on your home directory, this will always contain subdirectories. So there is actually, as we've seen, more to a shell command than just the command itself, because there's a general syntax to them. When we consider this command as a general example, which is ls space dash capital F space slash, what we see as an output, something like this. Again, this will look different in your machine. And what we have here is actually the command itself, which is ls. Then we have an option, which is dash F, which is also called a flag or a switch. And then as a third thing here, we have what is called an argument, which is the forward slash here. Options or flags or switches, what they do is they change the behavior of a comment. Usually, generally, they start with either a single dash or two dashes. And it's important to know they are case sensitive. So if you write different, like the same letter or same option in capital, non-capital, the behavior will change. And we can explore it, for example, using the dash S option, which, if it's non-capital, will display the size of the contents in the directory. So what we do now is we use ls space dash non-capital S space, and then provide it with a path, which is our argument right here. And if we run that, we get a list of all the files in this directory. And for each of the files in there, their file size. And we also get the total file size in this directory. So this would be the command line equivalent to what you do with clicking on a file or a directory, and then I only know it for Mac and Linux. It's like get information on that or further information, then you see how big it is and how many files in there. And this is basically how you would do that in the command line interface. So now what we're going to do is we basically run the same thing, but we don't write a non-capital S, but a capital S. And what it will do, it will basically sort the contents of the provided directory by size. So what we get now is a list of our content, same as before, but we don't get file size, but the output is listed based on this file size of each file. So the first file is the largest. And what happens if we type an invalid option? So if we type ls space dash j, well, again, we get a somewhat helpful error message, which is it's an illegal option, this one j. And then what you actually get here for the ls command is incredibly useful, because it already tells you if you want to use ls, those are all the different flags and options you can use, which is basically almost the entire alphabet except j. So now talking about arguments, or what's also called parameters, and these tell the command what to operate on. And they're only sometimes optional, as for example with ls. In these cases, providing them will change the behavior of the command. So if we type ls, just as we did before, we will get the files that are in our current working directory. However, if we now provide it with an parameter, an argument, that is here a path pointing to a certain folder, which is the one we downloaded before. So it's desktop/data shell/data. We see we don't get the outputs of our current working directory, but the outputs of this particular path folder. ls, as any other command, has lots of options. And there are different ways to find out more about them, where, for example, you could use man ls, which will get you to the manual page of this comment, or you can try ls or whatever comment you want, followed by -- help. And unfortunately, again, this will vary depending on the comment you want to run and your operating system. So rule of thumb, maybe generally try man first. So if you run that, you will get a lot of information as an output here for the comment of your interest, which now is ls. I'm just gonna show you how it's actually looking in bash, because if you type that in bash, so man ls, what you see here, you can use the up and downward pointing arrows to move up and down a line. You can use B or the space bar to move up one page. And if you're lucky and set up your bash in a corresponding way, you can actually also scroll within that. So this might not work for you depending on how you set your bash up. To quit and to get back to the actual terminal, just press a non-capital Q and you're back and can work again with your terminal. It's actually also possible to combine options. You can use multiple options at the same time. If the options are single letters, like the examples we did before, and it's in most cases with ls, you can combine them with the same flag actually. So if we type ls space dash non-capital S, capital S, and then our argument, which is the path again to data, we actually get the best of both worlds. So, because what we get is the output, this is the list of all our files in this particular directory, sorted by their size with their file size next to it. There are a bunch of exercises in the materials, and the materials are also shared and pinned in the Slack channel that basically help you familiarize yourself a bit more with shell and different comments and the whole logic and notion behind it. But for the sake of time, I'm just gonna skip them. And if you're further interested in them and checking out the materials later, you can definitely try those exercises. Don't worry, for each exercise, there's also the solution in there. But as with other things, please try it first without the solution. As we've seen before, we can actually also explore other directories. So providing an argument to ls lets us list the content of other directories besides our current working directory. And this we've done multiple times before. What you see here on my desktop, there's a bunch of screenshots I did for the presentation. So this is not a very good example, but that's just the reality. True first sometimes. So again, on your machine, this should look different. For those running on Unix-based system, Mac and Linux, this should actually match what you see on your desktop. For those of you running Windows Substance for Linux, this will be a bit different, unfortunately, because the way things mapped out there are not the same as doing like classic full-on Unix-based systems. For Git Bash users, so Windows without Windows Substance for Linux, I would assume it also tells you and shows you what is on your desktop. And what you can do with that now, and the greater scope of things regarding file system, so we can list the content of one of the directories on our desktop, for example, data shell, and we get the information on what's in there. But what we can also do is actually change to a different directory, because so far we've always ever been in our home directory and never changed the place where we are in the terminal in our file system. So we can actually now move out of our home directory. Again, please think about adapting paths if you get an error, depending on your operating system. So if I type cd space and then desktop, cd space data dash shell, and finally cd space data I should have moved out of my directory. The CD command in itself stands for change directory, as you see, yet another very useful acronym, and it changes the shell's idea of what directory we're in. So these comments here, one by one, will put us into desktop. So you place desktop on your file system, then data shell, and then data. Please note the lack of output here. So we don't get a response from our bash, right? It just does, and we don't get any information. And this is very normal for CD. So where are we right now? We can check that with our well-known command by now, pwd, and it actually tells us that we are where we think and hope we are. This is, for me right now, starting from root, users, my username, my account, desktop, data shell, and data. And to list the contents of the directory once more, here they are. As you see, we don't have to provide the path to data to this folder here as an argument, because right now we are in this particular folder and directory, therefore this is our current working directory, and we can just run ls without specifying an argument. How do you get out of there? As we saw, we can go down into directories and subdirectories, right? So the idea is always that the root is at the very top, and then you can descend into different directories. But how can you reverse that? What if you want to go back to data shell, which was one directory up? Can you just type data shell? Well, this is one of the options where CD actually provides you an output. If there is no such file or directory you can't descend into, go down into, then you will get an error telling you there is no such file and directory. So how we can actually go back up? Well, we have to use a special notion to move up directories, because CD can only ever see inside your current working directory, but not beyond in terms of like the parent directory structures. We have to type CD space and then ... And if we type that, don't get an output. That's already better than error, hopefully in most cases. And here, ... refers to the directory containing this one. And this is also called the parent of the current directory. And we can basically use pwd to check that we are where we think we are. And this worked just fine. We are back in data-shell. Talking about seeing the unseen. ls is supposed to list the contents of our working directory, but you might now wonder why we didn't see the ... anywhere in the listings from before, right? It was never there for us. The thing is that this ... is a special directory that is normally hidden. And you can provide an additional argument, an option to ls to make it appear, which is ls space dash the capital F, as we've done before. And now we also write a non-capital A. And what we see here is all these different things we did not see before. The -r argument shows all contents, will list all the contents of your working directory, including special and hidden files and directories, like the ... which again refers to the parent directory, and the ... which refers to the current working directory you are in. There's also not only hidden directories, there's also hidden files, where if you remember the last comment also read a .bash_profile file. So if we just run that again, here it is. And the prefix concerning files is usually reserved for what is called configuration files and prevents them from cluttering the terminal when you use ls. So that you don't, every time when you use ls, you see all those configuration files and hidden files. And another reason actually is also that depending on the architecture running on and things you do, those things are also hidden for another reason, that is, people don't by accident change them, delete them, adapt them, overwrite them, because depending on how these things work. For example, if you change the bash profile by accident, this might mess up your entire system, and it might be very hard to recover. So pwd, cd, and ls, these are some of the most commonly used commands you will ever use in the shell. So let's learn a little more about them. If we just type cd without anything, it, comparable to ls, takes no arguments. But where does that bring us? We can check again with pwd. It will bring us back to our home directory. So, might sound weird right now, but this is very, very useful. It's incredibly useful if you've gotten lost in your file system. So if you go really wild and bonkers throughout your file system, CDing wildly around, don't know where you are and how to go back, just type cd and you're back in your home directory. So for example, if we go back to the data directory within data-shell on our desktop, and then type pwd again to verify that we're really there. That's all good. What you see here, what we did not talk so far about, you can also use the /separator to basically string different paths together. Think about what we talked about at the beginning. That is the /separator or the slash character in itself either refers in itself to the root directory at the very beginning of your file system, or as a separator between different paths, between different directory levels. So instead of typing cd desktop, then cd data shell, then cd data, we can just basically append all these different paths using the /separator instead of changing one directory one at a time, and it also brings us there where we want to be. And this brings us to the discussion about relative versus what is called absolute paths. So far, we've only exclusively been using what is called relative paths to change directories and list their contents. A relative here indicates that the path is relative to your current working directory. That is, it only can descend, only subdirectories. The alternative is in what is called absolute path, which includes the entire path starting with the root directory. So from the very early beginning, the first thing in your file system, the /. And this is what's always going to be printed with pwd. So if you type and run pwd, we'll always see what is called the absolute path based on the very early start on your file system. You can also provide absolute paths to these comments, and they will work too. So instead of just running cd desktop data shell, we specify the absolute path to data shell beginning from / and then users. And this just does the same thing. As you can see, running ls-f again, you see all these different directories and files. If you hear a siren noise and like a siren right now, I'm sorry. This is the snow removal team going to my street. Should be over soon.
Yeah, we can hear it, but it's background. You're fine.
Okay, sorry. Almost done. Some helpful shortcuts. The shell will interpret the tilde character as your home directory. So whatever this is on your machine, where you are right now, the tilde character refers to your home directory. So this actually means that if we type cd space tilde, cd, or cd, the path to your home directory, this will all get you to the exact same place because they all mean the exact same thing. So if we type cd space tilde and run pwd, we are back in home. So we can also use this tilde character because it maps to your home directory to save some space maybe when you type comments. If you're unsure what your home directory actually is, you can find out via, yet again, using an environmental variable that is $all caps home. And it's just the same thing as we did with $all caps shell before. So if we run that, we see what on the machine we're currently on is the home directory. There's also the dash shortcut, and the dash will interpret the shell will interpret the dash character as wherever you were last. Unlike ... which moves us up one directory, if you've seen before, the dash character will bring us back. So we were just in our data shell directory before we changed it back to home. So if we type cd space and then a dash, we see this will bring us back to the directory we've been before, the prior directory. So all of these things make it basically easier for you to get around your file system a bit faster. Then we have some more exercises, again, skipping those. Some key points. The file system is responsible for managing the information on your disk, on your machine. Information in itself, as we've seen, is stored in files, which themselves are stored in directories or what you might call folders. Directories can also store other subdirectories, and this forms a directory tree, which we've seen in the beginning with our example file path. CD, and then providing a path as an argument, changes the current working directory to whatever path you indicate here, and doing the same with ls will print a list of specific files or directories. ls without anything just gives you the list of the current working directory files. pwd will print the user's current working directory. The / on its own is what is called the root directory of the whole file system on your machine. A relative path specifies a location starting from the current location, whereas an absolute path specifies a location from the root of your file system. Directory names in the path are separated with different slashes, a / on Unix-based systems, such as macOS Linux, or if you use the Windows subsystem Linux, but it's a backward slash on Windows. Always remember that. So for example, if you use your Windows machine, and there use the shell to access a remote machine that runs a Unix-based system, which most likely will always be the case, think about adapting, changing those paths, these slashes. A ... means the directory above the current one. A single dot on its own means the current directory. Now, actually, to start working with files and directories, how do you actually make new files and directories from the command line? Again, just remind ourselves where we are. We should be in desktop data shell. We list our content in there, which is a bunch of different folders. We got some text files. We got a PDF in here. How do we actually create a directory now in that folder, in that particular place on your file system? Well, you can create new directories with what is called the mkdir, make directory command. And this works as follows. You type the comment mkdir space, and then whatever you would like your new directory to be named. This, for example, thesis. One of those comments again where we don't get an output. And since we provided a relative path, right, we just provided a name, in this sense a relative path, and this didn't specify anything starting from root, we can expect that we have created our directory, this new folder, in our current working directory. And we can make sure of that using ls space dash capital F, and here we go. We see our newly created directory called thesis. What you also could have done, going back to graphical user interfaces, is using your file explorer or whatever you use on your machine and make a new folder that way. But let me tell you, once you start using bash in the terminal and start doing it over and over again, very soon it will just be way faster to use bash and terminal for these things instead of graphical user interfaces and click-based comments. Some good naming conventions. Please don't ever use spaces when naming directories or also files, because what it happens in bash and the terminal is that a space basically marks the differentiation between, for example, a comment, an argument, an option. So if you use spaces, the bash will interpret this not, for example, as one directory, but as two different things. And then almost all the time you will receive an error in response. Don't begin the name with a dash. However, you can use a dash within your names. That is fine. Maybe please stick with letters, numbers, and dots, dash, and underscores for your file names. That is, avoid other special characters like the ones you see here, which is what you might write when your supervisor once more ignores your comments. Creating a text file, because what we did before was creating a directory. How to actually create files? And let's navigate to our so far empty thesis directory and then create a new file. So as we're already in the data directory and we still use relative paths, we can just do a cd thesis to go in there. And then you can actually make a file via the following command, which is called touch, and then a space, and then whatever your file should be named, plus the extension. So here we're going to create an empty text file .txt, which is called draft. Again, we don't get an output for that. And we can see that it actually created a file, and that is empty because we didn't specify anything further using ls-l, or we could also use the s command as our flag as we used before. And we see our file is here and it's empty. Moving files and directories. Once we have created those things, how we can actually change where they are. Let's start by going back to data shell. What we have in data shell now is a directory called thesis, and within that a file called draft.txt, which in itself maybe isn't very informatively named. So we can what is called move it. So we type mv, yet another very helpful acronym for this comment called move, a space, then we provide the relative path to our file, a space, and then we provide relative path to whatever we would like that file to be moved to, which in this sense means renaming. So, and right now we would like to rename draft to quotes. Move is also in this group of comments that if any, like most things work, you don't get an output. And what we basically done here with move is the first file is what we are trying to move. And the second one, or here the last argument, is where we want it to go, where we want to move it to. And just make sure that it works. So we do ls thesis. And what we see, what's in this folder directory, it's one single file called quotes.txt. So we efficiently moved it, or in this case, renamed it. You can actually provide more than 2 arguments to move, as long as the final argument is a directory, which would mean that move all these things I specified before into this particular directory. An important note concerning move, it is actually quite dangerous because it will silently overwrite files if the destination already exists. As you've seen before, we didn't get an output. And if there would have been an output already called quotes.txt, it would have just have been overwritten. And that's it. Move will not tell you that is something already there and this is overwriting something. If you want this option, you can use the dash non-capital I flag, which stands for interactive moving with warning. So if you're trying to move a file and, for example, this already exists and would be overwritten, move then tells you that this is a problem and asks you to proceed or not. More remove. We can actually also move files in the traditional sense, or what you think about when you think about moving. That is, we can move them from a given directory to a different directory rather than just renaming them. So for example, if we want to move quotes.txt somewhere else, so think about relative paths again. We are now in data, and in data we have theses, and within these we have quotes. And if we want to move it now to our current working directory, which in bash we can indicate with the single dot, we can just type it as it is right here. Don't get an output. So what should have been done right now is we should have moved quotes out of thesis and into our current working directory. So if we check that, thesis is now empty, no file in there. And if we check if quotes is in our current working directory, we see it's here. So we moved it to the data directory where we're in right now. An important note on what we just did with ls, if we provide a file name instead of a directory, this will only list this file if the file name, if the file in itself is existing. Otherwise, it will throw an error. This is also a nice way to easily figure out if a file is there or named the way you expect it to be. We got some more exercises for you coming up. And another thing we can do instead of move, where we'll just overwrite things as we did before, is we can actually also copy files and directories. So we can use the cp or copy command, which copies instead of moving. So if we want to copy quotes.txt into a new file or create a copy of it, we can provide it with a path and actually a new name if we want to. So we can copy quotes.txt to a file called quotations.txt within the thesis directory. We do that and then check if it's there. So with ls, we now check if quotes and this newly created files are there. And we see both are existing. So not only can you copy these things, or just as we did with move, but you can basically in one go also change the file name if you want to. You can use the -R flag, which stands for recursive, to copy a directory and all its contents. You don't have to type cp for every single file or directory you want to copy, but can just use -R. So if we want to copy everything that is in thesis to a folder called thesis backup, which, let me tell you, that is always a good idea to have a backup of your important stuff. We can check if that worked using ls, pointing it at the directory now, and we see in thesis and thesis backup in both directories, we have the same files and information. And of course, right now with one file and directory, this is not very maybe impressive, but just imagine your whatever project folder you're working on with hundreds of files. Just making a copy out of that with one line of code is very handy. We got some more exercises. Yes. The last thing we talk about concerning directories and files is removing them. So let's go back to data shell. And then we're going to remove the quotes.txt file we created. And to remove files, we're going to use the command rm space and then followed by whatever we want to remove. The comment just deletes files, and we can check if the file is actually gone by typing ls. And we see now this file is non-existent, at least in our current directory, and we got the error or the message, there's no such file or directory. Very important, deleting in bash or terminal is forever. The shell does not have a trash bin. So usually what happens if you delete a file or remove files using a graphical user interface, it will not be immediately deleted, but it will be moved to your trash bin, to a trash folder. It's also a directory on your file system. And then you have to go to this directory to actually delete files forever. However, in bash and terminal, this is not the case. This doesn't have a trash bin. If you delete something, you cannot recover files that have been deleted with RM. If you delete them, they're gone, so no chance. However, as compared to move, you can also use the -i flag to do things a bit more safely. That is, it will prompt you to either type yes or no, indicated by caps Y or caps N, before every file that's going to be deleted. So if you're not sure if there's anything in there that should better not be deleted, just use the -i flag, and then you can just say, okay, please don't delete this file, but for all the others, you can say yes. Removing directories. So if you try to remove the DSys directory, what will happen is RM does not operate on directories. It tells you that, saying that this is a directory. I can do anything here. By default, it only works on files, but you can tell it to recursively delete a directory and all its contents with the -r flag. So before we used -r for recursively copying files and directories. Now we do the same, however, removing that. So if we type rm space -r and then DSys directory, we get no output because deleting is forever. That's the command we use right now. Always should be used with great caution, or at least with the -i flag to make it interactive. And then got some more things coming up. But I think, yeah, we are basically at the end of time of this lecture and lesson. There are more things in the materials. That is, for example, using different write card for accessing multiple files at once. And as said before, you have all the materials and slides pinned in the Slack channel group 1. And there are different ways for you to go through these more advanced options and things you can do there. I'm just going to skip to, sorry. Now I got it. Go back to, here we are. Okay, back to the key points for this thing. If you use copy, for example, old and new, so old file, you want to copy to a new file, copies a file, we can create a new directory using mkdir. We can move or rename files or directories, can remove them. Then we have different wildcard options to specifically query for certain files. And I can't stress this enough. The shell does not have a trash bin. Once something is deleted, it's really gone. And the maybe overall summary, the bash shell is very powerful in itself. It offers a command line interface to your computer and your file system. It makes it very easy for you to operate on files quickly and efficiently, for example, concerning copying, renaming, and what have you. And you can use sequence of shell commands, strung them together to quickly and reproducibly make powerful pipelines for various things you might want to do on your machine. And with that, I'm done and up for questions, if you have any.
Okay, there's a question which I think is going to be pretty useful for most people, which is there any way to find all targeted files in all subdirectories? So I think that one of the things that was kind of mentioned was find, and then I don't know if you mentioned globbing.
We have, yeah, like in the very end of the materials, there is a section on finding files and finding things and how these things work. And it's globbing in terms of like, for example, if you want to just list them, how you do that with just like wildcards, but also to actually use the find command in Bash. So that's at the very end of the materials.
So hi everyone, I'm Kendra, and I'm going to be talking about Git and GitHub today. And a lot of this material is borrowed from the tutorial by Software Carpentries, and I'll share the link later in case you want to go through it yourself. So the two goals for today are that by the end of this tutorial, you should be able to explain why Git and GitHub are useful and be able to track and share your work using Git and GitHub. So first, let's go over the setup to make sure that everybody is ready. To follow on your own machine, you'll need Bash, which you should have just used. You need to have Git installed. You'll need a text editor and a GitHub account. So let's just check that you're ready. And I'll just launch a poll.
We can see the poll.
Awesome. Okay, so select all that apply. Once you can open a text editor, go to your GitHub account, and when you open your Bash shell and type git --version or git space --version, you should see a version number. So it should look like this. Although you'll probably have a different version number than me. If it's saying something like it is not installed, you might have to run this code. I'll just wait a second because so far we only have 13 people who have responded. If you have a specific problem, describe it in the Q&A and someone can answer it. Somebody in the chat said I got Git version 2.3 Windows. That should be fine. I don't think the Git version will matter very much. The important thing is that you have Git, and this is an easy way to check that you have it. So far 17 out of 24 people have responded, so I am going to continue. Again, if you have a specific problem, say so in the question and answer, the Q&A, so that someone can answer it and the answer will be with your question, because in the chat it can get lost a little bit. All right, so now we're going to quickly configure Git, and I'll also paste this in the Slack so that if you get behind, you can go back and see this code. So essentially here you're telling Git that it should label all the commits you do, and we'll talk about what a commit is later, but it should label all of them with your ID. And this will also be used to link to your GitHub account to allow you to actually push and pull things from your to and from your GitHub account from your own computer. Somebody's getting the error, unable to fetch some archives.
It was fixed immediately afterwards.
Okay, cool. I never tried Nano. I'd love to try it. Is this a text editor without an interface? No, I think Nano has a interface. Oh wait, no, I think it's in the terminal, yeah. So you'll need special like commands to try to exit and save and stuff. So if you want to try it, go for it. I'll be using gedit from Linux because it's just more intuitive for people who haven't used a terminal-based text editor before. Okay, cool. Looks like all the questions are answered, and I'm going to keep going. But again, I just pasted all of this code in the Slack, so you can even copy and paste it if you want. Oh, when you're done, click raise your hand. Sorry, I forgot to do that. have said that they're ready, so I'll keep going. And again, you can get the same code in the Slack after I move on for this slide. Somebody's asking, is version 2.14.3 good? Yeah, again, the Git version doesn't matter too much. Just asking you to check the version is an easy way to check that you have Git installed. So I'm just going to lower all hands now. Cool. So respond yes if you're comfortable with Git already. So essentially using these commands and with GitHub. I just want to see if some people already have some experience with this. Should we see any output for this? I'm actually not sure. It's been so long since I ran it on my computer since I set up Git. Do any of the other panelists know? I'm looking at the question in the Q&A.
Yeah, I don't think so, but I can just run it real quick.
Okay, cool. Yeah, like Vincent said in the chat, any version of Git should be okay. We're not using the most recent new features of Git. So it looks like a few people are comfortable with Git and GitHub. So I'll be, since you're more comfortable, if I ask a question and say like answer in the chat, maybe like wait a minute so that since you might already know the answer, you're not just giving the answer. So it'll give people learning a chance to test what they're learning.
So to answer the previous question, so there should be no output for that.
There should be no output. Okay, awesome. Okay, so I just wanted to make a quick note on learning Git and GitHub. It can be quite overwhelming at first. It's very complicated. There's very many commands that you could possibly use, but something that I reflected on after learning Git was that I was doing it for a long time before really understanding it. And I think this is probably the experience of a lot of people where you're just doing it, you're using commands kind of like a machine yourself, and then all of a sudden at some point something makes sense, and then you keep using commands and then something makes sense. So don't worry if you don't understand exactly how it all works. The important thing is that you have a few commands, like you understand why it's useful, and you have a few commands that you can use day to day. So just a quick note, when you need me to slow down, say something in the chat. And when you have a specific question, ask in the Q&A, because if you ask in the chat, it's going to get lost. Because sometimes I'll be asking people to answer questions in the chat. So your problem questions will get lost in the chat. Is there a question on Slack? There is a question on Slack about core. Okay, I'll let one of the panelists answer that question in the Q&A, because that's not what I'll be talking about today. So here's a roadmap for today. We've already gone over the goals quickly and the setup. I'm going to go on to answering the question, why use Git and GitHub, and then look more into how it works. So where does Git store information? How do I record changes in Git? And then moving on to GitHub, how do I share my changes on the web? And then we'll revisit the goals to make sure we've met them, and I'll give you a peek at what else you can keep learning and suggest how to keep learning. So this is kind of the quintessential comic for explaining Git, and I'm sure many people can relate, where you think you've finished something, then maybe you submit it to an advisor and they give you revisions, so you revise it, and then you save it as a new file so you're not losing that previous version. And then you get more comments, and then you do more revisions, and it goes on and on and on, and eventually you have 30 copies of the same file, all with different names, and some version of this is the final file when really it wasn't. So this is a problem that's meant to be addressed by something called automated version control. So version control records versions of a file by tracking changes, and it's like having an unlimited undo button. So instead of saving each of these papers as a separate file, like final 1, final revised 2, final revised 3 or something, you just save what's in the middle of the files, which is the differences between the two files. So you're saving the initial file, and then you're saving all the changes that you make. So basically, it's like when you're, say, typing in a Word document and you want to undo the last sentence you wrote. You don't, go back to the previous version of the file you saved. You just click undo, and it just knows what is the last change you made, if that makes sense. This is really useful for if you want to make independent changes. Say you want to try doing the same thing 2 different ways, or maybe you have 2 different people working on different parts of a project, say different parts of code or different parts of a paper, and then you want to integrate them. And another reason why Git and GitHub are useful, aside from just version controlling your own work, is for open science. So I like to think of open science as a buffet, and this idea is from Christina Bergman. And there are many different aspects to open science and open source, sharing your code, using open code, contributing to open source software is just like one part of open science. So it's something that you can take away from the buffet and try to incorporate into your own work if you want to do open science. So now we've covered why use Git and GitHub, and we'll go on to how it works. Yes, the presentation slides will be available. And actually, I didn't post it before before I started, but maybe one of the panelists can find the link from the group too.
It's pinned on general.
Oh, it is pinned. Okay, cool. There you go. So now we're actually going to do some things with Git, and then just think back to that graph I showed you about doing and understanding. Sometimes you have to do it before you really understand it. So let's do something. Open your bash shell, which is where you typed the git space -- version at the beginning. And we're going to create a directory. So you might have covered this morning with Pear. First, we're going to change directories to wherever you want to make the new directory. So I'm just going to go to my desktop. And now I'm going to make a directory, mkdir, and I actually named my directory this yesterday, so I'll use my middle name, Marie's Desserts. The reason why I'm using a different name than I did yesterday is I want to show how to make a GitHub repository eventually to link to this, and I already made one yesterday, so I'll call it something new. Now we're going to change directories into that folder that you just made. Oops. And notice I'm using the underscore here instead of a space. I remember hearing Pear emphasizing not to use spaces when you're naming things. All right, so now we're going to find out what's in our directory. So we're going to type ls for list the contents of the directory, and -a to show everything. This is a flag that shows everything, including the hidden files. So the files that start with like a dot. So I won't explain what these are, but essentially our directory is empty. But now we're going to make a Git repository and see what it does to our directory. So we're going to type git init for initialize a Git repository. And Git's really helpful. It usually kind of tells you what you did after you did it. So it's nice validation. So it initialized an empty Git repository in this directory. So you can see this is where I am. And there's this .git, which is apparently in my current directory. So let's see if it's there. ls.a, and you can see the .git file. So this .git subdirectory is where Git stores all the info that it needs to do version control. Again, if I'm going to quickly say something in the chat and one of the panelists will be like, hey, Kendra, slow down. All right, so now we've answered where does Git store information. And again, I wouldn't worry too much about exactly how Git stores information. It's pretty complicated and you don't really need to understand that in order to use it. And once you're used to Git, it's easier to understand those things. So now we'll move on practically to how do I actually record changes in Git. So right now on your machine, we have a workspace, which is our current directory. For me, it's Marie's Desserts. And we ran the command git init in order to initialize this .git folder, which is contains our local repository and also what's called a staging area, or the index, which we'll explain now. So in order to record a change, there are two steps. First, we're going to git add the change to the staging area, and then we're going to commit it to the local repository. And it's a little hard to explain, but I find this illustration really helpful. So git add is like taking all the people that you want in a photo and kind of arranging them. So this is like taking all the changes that you want to snapshot and putting them together on stage. And then git commit is you actually take the snapshot. So let's try this out. Let's make a change. First, we'll open a new file. And just so you know, this, I don't know what these brackets are called. This in the pointy brackets where it says text editor just means insert whatever name of the text editor you're using. Or you can just open the text editor if you want and create a new file. We're going to call it desserts.md. And MD just stands for Markdown. And it's a type of text formatting, and I'm choosing to use it because you'll be working in Jupyter Notebooks, and the text part of Jupyter Notebooks is Markdown. So I thought I'd introduce that concept now. So I'm going to use gedit. I'm going to do gedit desserts.md, and since there's no file yet in this directory called desserts.md, it's going to create a new file called desserts.md. So there it is, desserts.md. I'm going to list some desserts: pie, ice cream, cookies, and then I'm going to save it. I just clicked Control S to save it and exit. There might be different ways for you to save and exit depending what editor you're using. Like in Nano, it's all within the terminal, so there's a certain keyboard shortcut for saving and exiting. Yeah, so maybe something to explain briefly is that gedit, it's not a word processor like Microsoft Word or like LibreOffice. The only thing you're saving is what you're typing, whereas in Word there's all kinds of formatting and extra things, and it's very hard to track anything in Word on using Git. That makes sense. It'll probably become more clear why that is when we explore how Git is actually tracking changes. All right, yeah, let me know if you need me to slow down. Why MD as a file ending? I see it all the time with readme.md and GitHub repositories. I wonder if there's a reason for this file ending. So basically the .md stands for Markdown. And it's, when you save a file with the ending .docx, it means that you can open it in Microsoft Word, and Word will know how to format everything according to the information in this file. Markdown is a way of formatting text. If you go, let's just go on to GitHub and I can show you. So here I have a README on a GitHub repository. This file is called readme.md for Markdown. And this is what it looks like, but if I go into the file and see what it looks like in the raw format, you can see like this title was formatted by adding a number sign. I made things bold by adding these asterisks and so on. So it's just a language for formatting text. And if any of the panelists have a better explanation, feel free to write it in the chat or the Q&A. So now let's check the status of our repo. So far what we've done is we've just created a file, we've added some content to the file, and we've saved it. So git status. So I want you to just look at the message that Git tells you and answer this question, which I think I've just launched. No. Polling, oh, it says polling is closed. I
think you have to relaunch polling with the new poll.
Okay. Continue. Okay. So just read the output that Git gives you and think about whether this file is being tracked by Git.
Kendra, there's a couple of people not being able to launch their text editor from their terminal.
Okay.
Maybe just a quick word on that?
Yeah, so you can also just open it from, say, if you're on Windows, from the, I think, I'm sorry, I don't know the name for all the Windows things, but you know how you can type in the name of an application to open it? You can open it in that way. On Linux, if actually, I'm not sure how this works on different keyboards. Does somebody who has a Mac want to say how they're opening their text editor other than in the terminal? Because I don't have a Mac. Maybe Per knows if he's paying attention. If you're not able to open a text editor, can you just put something on the Q&A with your specific operating system, like, hey, I'm on a Mac, I can't open a text editor, and then someone who's familiar with Macs will help you. You don't have to use Nano on a Mac. I think Mac comes with something called TextEdit, so you can try searching for that application. I'll just type it out here. It's TextEdit, all one word. Where should you save the notepad? You're saving the file that you're writing in Notepad. You just save it to that directory that you made, which would be maybe your name and then desserts. What does it mean tracked by Git? So if I go back to this illustration, basically it means that right now I can share the results. Can you see the results of the poll? I'm assuming you can. Okay, so you can see most people got the right answer, which is no, right now it's not being tracked by Git. It's under the list of untracked files. But once we start tracking it, it's going to take a snapshot of what it looks like at the beginning. And then every time we make a change and save another snapshot, it's just going to track the changes between the original file and the current file. Does that answer your question, Safa? Again, like the nitty-gritty, what exactly is Git doing, you could look it up, but I would say just trust that it's tracking it, and then eventually once you use it for a while, it'll start to make sense. Yeah. Okay, someone just said for Mac, you can type, if you look in the chat window, Karadak has just said for Mac you can type touch and then the name of your file, and then do open space .a space text edit space your file name. Okay, if anyone is still having trouble opening a text editor, can you raise your hand? Great. Okay, so I'm going to move on. Just a reminder for those who just got a text editor opened, you're just making a file called desserts.md and then adding a list of 3 desserts. So now we're going to stage the change. So again, Git is really helpful, and it actually tells you how you can stage the change. So use git add and then the file name to include in what will be committed. So including in what will be committed is another way of saying staging the change. So git add desserts.md. And now that we've done that, let's check the status again. So we're going to do git status. And you can see last time we did it, it was under untracked files and it was red. Now it's under this heading changes to be committed and it's green. So it's saying we've detected a new file called desserts.md, but it's not committed yet. So Git is not, has not taken the snapshot of the file yet. And now we're going to commit the change by doing git commit -m, and the -m just means we're adding a message to the commit. If you don't do this, it'll open a text editor for you to add the message, so it's easier if you just do it all in one line. And this message is what you're going to be looking through later when you're trying to figure out what you did in each snapshot of the file. So make sure it's actually descriptive of what you actually did. So in this commit, we made a list of my favorite desserts. And there we go. So Git is very nice and tells us what we did after we did it. We changed one file. 3 insertions means like the file has 3 lines in it. And if we do git status again, you'll see there's nothing to commit. The working tree is clean, which means there's no changes. There's no difference between the current working directory and the snapshot that we made. Oh no, we forgot cake. So we're going to open the file again, and so for me, I'm going to type in gedit desserts. If it's a real bother for you to open the text editor, you can also just keep it open. You don't have to exit every time. For people using a text editor like Nano, which is in the terminal, you do actually have to exit because you have to get back to the terminal to keep doing things. So let's add cake to the list, and I'm going to save it, and I'll exit. There we go. Can I please scroll up? I cannot see the end line. Oh yeah, sorry. That's why I when you, at least on my computer, when I click Control L when I'm in the terminal, it kind of erases whatever is in. If I'm typing at the bottom, I can't actually scroll. So now let's see what Git tracked, and we do this by typing in git diff. So if you want to see what exactly this command does, you can do git diff --help, and you'll see this nice helpful manual. It tells you the name and a brief summary of what it actually does. You can show changes between commits, between the commit and the working tree, etc. There are different options you can use. I'm pressing Q to exit this manual, and we're just going to do basic git diff and see what it shows us. So yeah, so here you can see basically it's showing the difference between two versions of the same file, and this is what is different, the thing that's highlighted in a color, and also has the plus sign to show. So because it's green and because there's a plus sign, it means we've added this line. Let's check the status of our repo. So can you just type in the chat what you think the command is to check the status of our repo? And I'm pretty sure by default the chat only shows up to the panelists, so you don't have to worry. Well, you don't have to worry either way about if you get it wrong. It's a learning process. So right now one person has answered. Seems like we're a little chat shy today, but she got the right answer. It's git status. Yeah, okay, a few people are getting it now. Awesome. And again, we see changes not stage commit. So there's been changes made to this file. So here it says modified. Before it said either created or new file or something that indicated that there was a new file not tracked. Now it's just saying this file that is tracked has been modified. So let's stage and commit the change. So in the chat, say what you think which git command we would use to stage the change. And again, the message that git sends you is helpful. Question, how did you come up with the A/desserts_MD name? Is that always A/B? Oh, this A, okay, I think, again, I think this is just Git's way of saying there's two different versions, the current version in your directory and the one that they've taken a snapshot of. Do any of the panelists have a better explanation? I didn't actually name it A or B. I think it's just a way of Git tracking that these are two different versions of the same file.
That's correct, Kendra.
Yeah, okay. So yeah, again, I'm not sure, this might be a folder within the .git folder that we saw before here. But essentially it's just Git saying these are two different versions of the same file, version A and version B. But really the part that I look at when I do git diff is this part. It actually shows you the contents of the file and what has changed. So git diff records the difference between our previous commit and the current files. Well, if we do git diff --help again, you can see it can show the changes that happen between commits or between the commit and the working tree. So yes, it can do that, what you said, Karadak, but it can do other things as well. So by default, when we're just doing git diff, what it's doing is showing the difference between the current working tree and the last snapshot that Git took of the file, the last commit. But if we had more than one commit, we could also do a git diff between two previous commits. So if I do git log, this just shows the history of the different commits. You can see there's only one, and the commit was list my favorite desserts. So we can't look at a difference between commits yet because we only have one commit. So we're going to git add. Good, a few people got that. Desserts.md. And then we're going to do git commit. Again, we're going to add the message with the .m flag. And we're going to do a descriptive message of what we actually did in the change. So we're going to add cake to list of desserts. And now if I do git log, you're going to see that there's two commits. there's the one that we just made is at the top, and the previous one is below it. So can we look at the difference between two documents in different folders with different file names? If by document you mean like a Word document, Git doesn't track Word documents very well because the contents, like what you're actually typing, isn't stored in the same way as a text editor with like each letter. But say you had two markdown files, I'm not sure, but when we make another one, we'll make another markdown file and we can try that out and see what happens. But really, that question kind of goes back to the idea that when you make a different version of the same file, you save it as a different document name, like document name _ final, the real final one, blah, blah, blah. And that's kind of what we're trying to avoid with Git. So the point of Git is that with a file, you're tracking each change and then saving the snapshots so that you don't have to save like a new version of the same file. When I type git diff -- help in Git for Windows, it opens this in my browser. Yeah, so Git for Windows might be a little bit different. I'm assuming that's normal because that's what happened. If I would look up like git diff help, I get this, and then if I hit git diff -- help, you can see it's actually the same thing. So I'm sorry, I don't know how to pronounce your name, but Thibault? Is this what you're seeing? Yes. Okay, cool. Thibault. Okay, cool. All right, it seems like even though I named my file .md, it added RTF to it. Does someone like Jerome want to answer that question? You're more familiar with text. Different text.
RTF is a WordPad extension. So
okay.
Windows does this very sneaky thing that regardless of what you name it, it'll tack on some extension.
Okay.
So presumably they're using RTF. So their file is probably called something like name.md.rtf, which is super annoying.
Okay.
It's one of the reasons not to really use Windows in development environments.
Yeah. So Windows has a few quirks. I think the main source of the differences with Windows is that it uses a different basis for the operating system. Both Mac and Linux use a Unix-based operating system, and Windows it's just something else. So whenever you want to do the same kind of things on Windows and Mac or Linux, you have to kind of do special things to get it to work in the same way because it has a different basis of the operating system. Can we show the difference? Oh, yeah, Lex probably can say this much better.
Oh, no. So I was just going to apologize to Windows because apparently they're on Mac, but the issue is the same. So redirect all the hate I had for Windows just now and then redirect that to Mac.
Okay. Yeah. Okay. Can we show the difference between our two commits? Sure, we can do that. But this is going to be a good illustration of you probably will never just remember off the top of your head how to do everything. So I might have to figure it out. So I'm going to do git log to look at what the two commits are. I'll do git diff and kind of shortcut. You can either refer to a commit by taking the commit this hash, which is the tag for the commit. Or an easier way to do it, I find, is just to refer to it as head, which is head here, and then do back as many commits it is. So if it's a commit a really long time ago and you don't want to count how many commits back it is, this doesn't work very well, but we only have two. So Let's do the difference between this and, oops, the previous commit and the commit 2 times back. Okay. Okay, so here, this is a good illustration of how to figure something out if you don't know how to do something. So here somebody's giving this answer on Stack Overflow, which is a website where people ask questions mostly about programming type things. And so somebody asks a question and then it's answered and people can upvote or downvote answers. So you can see this has a lot of upvoting, so I'm going to kind of trust it. So here they're doing, this is just the first, what is it, 7 letters of the commit hash. So let's try doing that instead. What is my patch? Any of the other panels want to?
Oh, that just redirects the output from getDiff, doesn't it?
Okay, well, I'll try it with, oh yeah, probably it puts it in this file. Okay. I'll just try it without the my patch part then. So getDiff, let's do, and then it just has a space. Oh, there we go. Okay, so I just took the first part of each of the commit hashes. You could also just copy and paste the whole thing. Probably would actually be easier. But so it's showing that the difference between the first commit and the second commit is that there's this cake was added to the list, or because of the direction I did the comparison, it's showing that it's removed. So if I would do it the other way and do the second one first. So this is the first commit, and this is the second commit. Now it's going to show that cake was added. So here it said cake was taken away because I was comparing them backwards in the actual timeline of what we did. Does that make sense?
So somebody pointed out in chat that the getDiff that you used previously with the head at ~1 and ~2 should probably be ~0 and ~1.
Yes. Okay. So this is something I always get stuck on with different programs, is whether they use 0-based indexing or 1-based indexing. I'm sure in Python you talked about how Python uses 0-based indexing. So there we're getting the same thing. And if we change the order, and if you're wondering how I'm getting back to this command that I did previously, I'm just hitting the up arrow and it shows me my previous commands. So I just switched the 0 and the 1 now to actually see it in the temporal order that we did it. So this is the 2 commits back, and this is the most recent commit, and you can see we added cake. And I just clicked Control L to get rid of all that so that you can see what I'm doing. Okay, let's go back to the slides. Did we actually do this part? Yes, okay. Okay, so one more change, and it is for a reason. So I changed my mind. Cookies are actually better than ice cream. So let's go back into the file, gedit desserts.md. Again, type in your text editor name or whatever, use whatever way works on your operating system to open this file. And I'm going to get rid of cookies and then put it in front of ice cream and save it and exit. So we're just changing the order of cookies and ice cream. Or if you used your own desserts, just change the order of 2 of the desserts. All right, so now we're going to run getDiff. And we've talked a lot about getDiff now because of some questions. But in the chat window, can you type, how could we figure out what this command does. If you remember, there's something that I typed in the terminal here that allowed me to figure out what it does. Again, if you have really specific questions, it's better to ask in the Q&A, because I'm going to be asking people to type stuff in the chat window. So like your thread of getting your question answered might get a little bit lost in the chat window. In the Q&A, it's a little easier. Good. Okay, a few people have got it. Git diff -- help. And you can do this for any git command. You just type the command and then -- help. And it shows changes between commits or between commit and the working tree. So let's quit this manual by pressing Q. And now we're going to stage and commit the changes. So in the, okay, someone's still going through a question in the chat box. So in the chat box, just type in the two blanks here. And this might seem very, very repetitive, but basically you need to like repeatedly do this until it's in your head. These few essential Git commands before it is easy to get it to be part of your regular working every day. Sorry, I'm losing my language as I try to read. Yeah, okay, cool. A few people got it. So we're going to git add desserts to save the chain, to stage the change. And again, this is like getting everyone into the place where you want to take a picture. If we had done like a whole bunch of changes to different files that couldn't be described with one cohesive message, we wouldn't want to just add all of them. We want to add a few that can be described with a cohesive commit message, and then do another add for a different change, and so on. So this is why there are these two steps for git add and then git commit. So I'm going to do git commit, adding the -m flag to say that I'm going to add the commit message right away. I'm going to switch cookies and ice cream, because clearly cookies are better. There we go. And git tells us there's one file change. There's one insertion and one deletion. So if we, yeah, here we go. So we're going to check your understanding now, and I'm asking, what does git track? We talked about this briefly before, but in the chat window, just answer like yes or no. Does git track changes to each letter in the document? I've got one answer so far. No, it doesn't matter if you get it wrong. I'm just curious what people think so far. Yeah, you can put a question mark if you're not sure. That's helpful too. So I'm getting some yeses and some no's. So let's actually look again at what is being tracked. So we'll do git diff. I just did git log so that I could see the different commits. Let's look at compare the previous two commits. So we'll do git diff and then head, where it is now. So -nothing versus head. Ooh, I guess I should go in order temporarily. So let's do head -1 and then head -0, so we can actually see the change in the order that we did it. So all we did is we switched cookies and ice cream, and if you remember, I actually, here, I'm just going to put this at the top. There we go. I actually backspaced cookies and then moved that, but what Git is recording is that I got rid of ice cream and then I added ice cream here. And one way we can really see this is if we go into our text editor, go into desserts, and let's just change one letter. Let's just make cakes plural. So I just add in an S to cakes. I'm saving. and exiting. And now let's look at the difference between, if we just do git diff without this head stuff, it's just the difference between our current working tree and the last commit. So here you see it actually recorded the change as I got rid of the whole line that says cakes, and then I added a new line, or that says cake, and then I added a new line that says cakes. So the answer is no. Git doesn't track changes to each letter. It tracks changes to each line. So even if you only change one letter on a line, or say like get rid of a space on a line, it's going to record it as you got rid of the whole line and added a new line. All right, so I'm going to launch. Oops, sorry, wrong poll. I'm going to ask you to put these in order and answer in the poll. So these are the 3 basic steps that you need in order to have Git keep track of a change that you're making. Yeah, so someone was asking about this Git hash. I'll just answer that while people are answering the poll. So if I do git log, you can remember at one point when I was doing git diff and using the git hashes to identify the different commits, I just took a few letters. So you could copy and paste the whole git hash, or you could just use a few letters. The important thing is that there are enough letters in what you copy that you actually distinguish the two. So I couldn't, for example, distinguish these 2 commits with just a 2 because it's the same. I'm just going to click Control L in my terminal just to clear what I've done so far. Okay, seems like no one new has answered the poll in a while, so let's end the polling and share the results. So you can see most people got the right order, which is first you make a change, then you add the file to stage the change, and then you actually take the snapshot, you commit the change last. So now I'm going to have you actually do these 3 steps and add your own favorite dessert to the list and track it. And when you're done, just raise your hand so I know when I can keep going. If you're having any trouble, feel free to say so in the Q&A. We got another question. So just typing git diff will show the changes between the 2 last versions. Not quite. If you just type git diff with nothing else, it shows the difference between the previous commit and what is different in your current directory. So if I do git status, you can see I haven't tracked this change yet. This is just a change that's done what we call on my working tree. So I just made the change. I haven't added it. I haven't committed it. So when I do git diff, it shows the difference between my working tree and the previous commit, which we see if you do git diff --help. You can use git diff to show changes between commits, between commit and working tree. Yeah, you can see all the different options for how to use it. One way to kind of figure this out is just try it. Just do different things, try git diff, see what it does. And honestly, just kind of playing with the git commands in a folder that doesn't really matter if you mess it up is, I think, one of the best ways to learn how to do Git. Okay, so Jerome just said between the working tree and the index, which is the stage changes. So if I do git add desserts to stage the change, and then I go git diff, you're not seeing any difference, but if I do another change and I haven't added it, then, well, let's try it. Gedit, desserts. Again, don't expect to remember what every single option will do. The important thing is that you figure out how to use a few commands in your work, and not worry too much about understanding everything. So I'm going to add a dessert, which is pulla, a Finnish dessert, which is delicious. Saving it, exiting. Oops. There we go. So if you remember last time, if you've been following what I've been doing, I made a change where I made cakes plural. I added it, and then I did get diff, and it didn't show any difference. But I haven't committed it yet. So right now, when I added the S to cakes, it's just in the staging area. It's just in that middle area. I haven't committed it yet. But now I did another change. So let's see what get diff does. So you can see that it takes, right now it's showing the difference between the current working directory where I added pulla and the staging area. So even though I haven't committed this addition of the S, it's showing the difference between those two. Kendra, could you do get status again? Get status, yes. So you can see that one of the changes has been modified, and this was the one where I added the S because I get added. I did the command get add after I added the S to cake. And then there's another change that has not been staged, which is the one that I just did, which was adding pulla. Yeah, so like Jerome said in the chat, I'm showing that some changes are staged and some are not. So if I did get commit right now, it would not track that I added pulla because I haven't staged this change yet. And I know it feels like I'm talking about a maze of get add and get commit and such, but I find it most helpful to remember it with this GIF that I showed before of get add is getting everything ready for taking a snapshot, and then get commit is taking the snapshot. Okay, I shared the results. There we go. All right, again, maybe you forgot, but just raise your hand when you're done so I know if everybody has successfully added their own dessert. I'm just gonna commit my change, or get add desserts. So now you see I did get add again, and even though before it had tracked one change and not tracked the other, now it's just showing that it's tracked changes to this file. So both of the changes are staged, and now I can commit with a useful message. And remember, both of those changes are now staged, so I have to make a commit message that is useful and captures both the changes. So I made cakes plural, add pulla. Cool. I only see 5 hands up. Again, if you were able to add your own dessert, raise your hand so that I know that people are getting it. Okay, I'm going to move on, but if people are really stuck, we'll come back to it. So now we know where Git stores information in that .git subfolder. Remember, we saw it here, this .git folder. We know how to record changes by making a change, staging the change by doing git add, and then committing the change with git commit. And now we're going to look at how do we share our changes on the web. Oops. Here we go. So basically, again, this is what we've covered. We initialized a repository, which you only have to do once in the repository. And then you make a change, you add and commit it. You can use git status to look at what changes have been made in the workspace and what changes have been staged in this index/staging area. And you can use git diff either to look at the difference between the index and the workspace, or between the local repo, which is where all the snapshots are stored. So this is comparing a past commit to what's currently in your workspace. And like we demonstrated, you can also use git diff just to compare two commits, like two snapshots that are in the local repo. So now we're going to add another command, which is git push, which basically pushes the snapshots from your local repo into your remote repo, which could be, for example, on GitHub. So now we're going to create a remote repo. So go to your browser and open your GitHub page. So I'm going to go GitHub and then my username. You should already have it open because at the beginning I asked you to open your GitHub account. I added dessert, but one item on my list is always displayed as red, as if it has been removed and then re-added in green, even if I didn't edit this item. This can happen even if you do something as simple as deleting a space or adding a space after, like on a line. It's kind of hard to know what exactly happened. Did you maybe add or delete a space, Stephanie, on the line that was displayed in red and then re-added in green? Another possibility is that you didn't actually do git add for the file. Yes, that's probably it then, yeah. So like I said, it records any change to any letter or a space as a deletion of that line and addition of a new line. So it records changes line by line, not letter by letter. Okay, so we're going to github.com. We're going to go to repositories and click new. And then we're going to give it a name. And just for simplicity, we're going to name it the same thing as the folder. So I'm going to name mine Marie's Desserts. There we go. Marie's Desserts. Right, and GitHub nicely tells you that the name is available. If you try to name it something that already exists, it won't let you, which is why I wanted you to put your name in the file name. So we're entering the name. You can choose whether to make your repo public or private. I'm just going to make it public because I'm just going to delete it later. Don't check any of these boxes, and then click Create Repository. If I'm going too fast, let me know. So now we're gonna, we have this repo on GitHub called Marie's Desserts. We have a folder on our computer called Marie's Desserts. Now we're gonna link the two so that we can push our work to the remote repo. Sorry about my Slack notifications. So basically we're gonna tell Git on our computer, we're going to tell it the URL of the remote repo, and we're going to name the URL origin just as a shorthand for this URL. So we do this by typing git remote, which just means we're going to do something related to remote repositories. And the specific thing we're going to do is add. We're adding a new remote. We're going to name it origin, and then we're going to paste the URL. So if you go to that, the GitHub page, a quick way to copy it is just press this little clipboard thing. And then paste it here. I'll just copy and, oh, no, that doesn't work. I'll copy and paste this in the chat so you don't have to do so much typing. So now we're going to set the name of the principal branch to main. So it might already be. So you can type in git branch just to see all the branches. And we haven't talked about branches yet. I'll talk about it in a bit. essentially, if you remember back to where I showed like one document branching off into two different versions of a document, that's the kind of thing we're talking about. But you can see I'm on a branch called master, but we want to rename it to main because GitHub by default, and I think some new versions of Git now are by default naming the principal branch main for reasons related to the Black Lives Matter movement this summer. It was brought to the attention of a lot of developers that the nomenclature of master isn't inclusive. So we're going to do git. Oh. It looks like the code actually isn't there. Let me find it. There we go. Sorry, I deleted this figure earlier and I accidentally deleted the code as well. So we're going to do git branch. We're setting the principal branch to be main. So now if I do git branch, you'll see that it's main. And now we're going to push the changes that we made locally. So we've added this remote and we've added a link, but now we're actually going to push the changes we made on our local repository on our computer to the remote repository. So we're going to do git push -u, and we're going to push to origin. Remember, we named this remote origin here when we added a remote named origin and then gave it this URL. So it's going to push to that URL. And what we want to push is the branch called main. And it's probably going to ask for your username and password. And just so you know, when you type your password, it's not actually going to show the letters you're typing. Yeah. And then we're going to go to the GitHub repo and refresh it to see the repository. So now you can see I have this repository on my account called Marie's Desserts. And it looks the same as the repository on my computer. There's this desserts.md file. It has this list. Right now it's rendering, it doesn't look like a list, but if I look at the raw file, you can see it looks like the list that I made. Where can I find the GitHub address from GitHub Desktop? I'm assuming you're on Windows, and I don't use GitHub Desktop, so I can't help with that. Maybe one of the other panelists can help with that. Yeah, exactly. Sorry. Lex pasted that code. I pasted it to the panelists on accident. So now we're going to explore how to use GitHub to look at your file's history. So on your GitHub repo, let's just go back to the main page. Let's click on desserts and then click on history. So what do we see when we click on a commit message? So you can see here, there's a list of the 4 commit messages that I've made so far. So what I want you to do is, sorry, I didn't put the chat icon here, but click on one of them. So I'll click on this one. And in the chat box, can you type what do you think you're seeing when you click on one of these commit messages? Was one of the panelists able to help? Xiao?
I'm typing.
Okay, cool. Yeah, so someone's got it. What you're seeing is essentially the same thing as you saw when you did git diff. But for that particular commit. So you can see in this commit, I added cake, which is exactly what I said in the commit message. So again, make sure you add, you use really informative commit messages so that later if you're trying to figure out like, what did it look like when I did this, you can actually find it because you're not going to remember these little hashes from the commits. So now what do you see when you click on these little pointy brackets? I should really figure out what the name of these pointy brackets are.
I think their actual proper name is angle brackets.
Angle brackets. Oh, okay. I was pretty close.
But, pointy is fairly descriptive.
Yeah. So I clicked on that the angle brackets, and it looks like I'm just looking at the repository, but let's look at the desserts file. You can see that cake is singular still here, and there's no Pula at the end of the list. So somebody want to type in the chat what you think you see when you click on the angle brackets? So I'm looking at the repository, but it doesn't look like the latest version. Well, now it does. Okay, let's go back to history and then go here. Anybody want to say in the chat, what do you see? What are we looking at when we click on those angle brackets? As a bit of a hint, if you just hover over the angle brackets, it kind of tells you. Content of the file, like we opened it with your text editor. Yes, we can see the content of the file by clicking on it, but it doesn't look like the most recent version of the file, say like on our computer. Like if I do edit desserts, and then compare it to desserts here, and let's just look at the raw so it looks the same. You can say it doesn't look the same. So again, if I go back to the main one and I click on the file and then I click on history, if you just hover over it, it shows, it gives you a hint at what clicking on it will do. So basically, if I click on this, I'm going to browse the repository at this point in history. So basically, I can go in and look at the repository and see what it looked like at that point in time. So if I click on this first one, and then I click on desserts, it's going to look like my initial file. So when I just had pie, ice cream, and cookies, I hadn't added cake yet. I hadn't made cakes plural yet. I hadn't added Pula. Yeah. So this is a really easy way to take a look at your work at different points in time. You can also do it like we showed in the terminal using git diff, but this is just a little bit quicker and easier. So I'm going to exit that. All right. So now let's revisit our goals and see if we've met them. So in the chat box, I want you to write a sentence or two on how you would explain why Git and GitHub are useful to a 10-year-old. So to someone who doesn't understand what is research, what is code, how would you explain why it's useful? And I'd encourage you to actually, when you write in the chat box, choose the two, everyone, all panelists and attendees, just so you guys can see each other's answers. You don't have to. If you don't want everyone to see your answer, you can do it just to the panelists, but it's nice to kind of see each other participating. So panelists, why don't you do this too and send the message to everyone just to get the chat box moving a little bit? Because Kendra says so. Yeah, I guess so.
if you're talking to a 10-year-old, that, that's not wrong.
Well, if you're talking to like my 4-year-old nephew, maybe that would work because he loves me so much. I was his Valentine last Valentine's Day. He didn't give presents to anyone else.
That's cute.
Yeah. Yeah, so we're getting some answers because you can have a clear, organized record of changes. Oh, it's hard to read when things are changing. Clear, organized record of changes in your work, yeah. Git and GitHub, it's useful if you want to know every step of your work, every state it has been in, or at least every step you wanted to save. Yeah, that's really good. It's like taking several pictures over a flower's life, except sometimes you need to go back to a step of the flower's life. Yeah, that's really good. I like that idea of the kind of like time-lapse photo of a flower's life. And so Git is useful, else you can't resurrect the flower to the state you wanted. Yeah, say like you get to the end of the flower's life and you're like, oh, this isn't nice anymore. I want to go back to when it was a bud. You can actually do that. But honestly, getting psychology collaborators to use it is virtually impossible, which is why I haven't been using it. Yeah, it's kind of hard to start using these things when the people around you aren't using it, but hopefully kind of as a field, psychology and neuroscience are moving towards using these tools because of the issues with reproducibility that are becoming more well known. I think the most important feature is being as open science source for everyone. Yeah, so sharing your work is really important. I guess to a 10-year-old, you could say, well, like I could say, this is true, but you don't know unless you actually see my work. Or like, it's like when your math teacher says, show your work, don't just give the answer. Like you might be able to calculate something in your head, but they actually want to see how you got to the answer before they believe it. Keep track of dessert overconsumption and recall New Year resolutions. Yeah. I kind of like sneakily used desserts because I thought maybe like people thinking of yummy food would put them in a good mood for learning about Git. And now, just quickly, how do you change this for a grad student? So actually, I guess some people have already been mentioning some research-specific things, but like say you have a new grad student entering your lab and you want to tell them why you use it and why maybe they should use it. You'll suffer anyway, but this will make you suffer less over time. Yeah. So if any of you have tried to like go back to code you wrote even a few months ago and like understand what it was, or like realize that you wrote this code, but actually it's some previous change you made it not work anymore, and now you don't know how to get it back to the working file. This is like a really good illustration of why Git is useful. What I often do is I do a git add and commit when something is working, or like when I'm just about to make a good big change. I take a snapshot so that if I completely mess it up, I can easily go back. Cool. Let's move on. So did we reach our second goal? So do you know how to track and share your work using Git and GitHub? So I want you guys to fill in these blanks, and I'm going to go to the next poll. Okay, so I want you to use these Git commands and put them in each of these blanks here. So the first few points are the basic workflow for tracking a change and putting it on GitHub. So this could be like making a change could be like you writing, say, a Python file to like load your data and do something to your data. How do you stage the change, commit it, and then put the change on GitHub? And then these are two commands that you can kind of use anytime just to see what's happening with Git. Kind of figure out what's going to happen if you stage the change, what files should you be staging, and so on. I really like that answer that Mael gave. You'll suffer anyways, but this will make you suffer less over time. It's an excellent reason for using it. How about branches? What are they used for? I'm actually going to cover branches briefly. I didn't go too much into branches in the part where you're actually doing things, because I think when you're most grad students will just kind of be doing their own project and then maybe want to share the code. So really the basic use of Git is like, how do I track my changes and then share it? Branches become more useful, especially when you're collaborating. They can be useful in your own work, but honestly, I think I went through like a year of using Git and GitHub without using branches at all. And they're kind of hard to understand, which is why I didn't focus on them yet. Where do commits go by themselves as they don't go to GitHub on their own? I can't exit this to show you my figure. Yeah, so Vincent just answered in the chat. It goes to the local.git file. So you remember in your folder, if you do ls.a, there's this .git folder, and that's where, that's your local repository. So remember, you have like a local repository and you have a remote repository. So when you're just committing and not pushing, it's only going to the local repository. Yeah. So think of this as like the photo album on your computer. Maybe you, like for me, I might call it like photos I want to put on Facebook. And then there's the actual album on Facebook in the remote thing. It's not an ideal analogy, but if you're thinking about commits as snapshots, think of it like a local album on your computer versus like an album on the internet. Cool. Okay, so I'm going to end the poll and share the results. So awesome. Almost everyone got it right, and the one that didn't was pretty close. So basically, we're going to add the change, then we're going to commit the change, and then push it. And if you want to see what's happening with Git, you can use git status to see like what's changed in your working directory versus the last snapshot versus what's in the index. And you can see that there's nothing to commit. The working tree is clean. I haven't made any changes since I did the last commit, basically. And if you want to see how a file has changed or like what your repository looks like at different commits, you can use git diff. Or if you're lazy like me, just go on GitHub because it's easier to do it from GitHub. So if letters changes are not tracked by git diff are words, what is tracked, or lines? So basically, if you change a letter or if you change a word or if you change like 90% of a line, Git is like for all of those changes, Git is going to track it as deleting a line and adding a line. So it doesn't matter how much you change in a line, as long as something's changed, Git's going to say this line was deleted, this line was added. Does that make sense? Cool. All right, so now I want you to actually use all these commands. Okay, so the whole line, yes. Yeah, so it's the entire line that, that Git is tracking. So now use these commands to make a new file called snacks.md. Essentially, you only need these 3 commands, but you can also see what's happening with Git with the other 2. And raise your hand when you're done so I know when to move on. And I'll go through it slowly here, just for anyone who can't remember. We're going to do the name of the text editor or open it however you know how to open your text editor. The file name. My computer's freezing. There we go. I'm going to add, I don't know, brownies. Save. Exit. I'm going to, so I've made the change. Now I'm going to stage the change with git add file name. I'm going to commit the change. So actually take the snapshot with git commit. And I'm going to add a really informative commit message. So add brownies. Oh, whoa, sorry, I'm doing the wrong task. Okay, I'll just finish this so my history doesn't get messed up. So sorry, I didn't actually make the new file. So get it, snacks.md. I'm going to list some snacks, popcorn, candy, save. Oops. Oh, sorry, the zoom bar is getting in the way. There we go. So I'm going to add that file, which is taking the initial snapshot of the file. I'm going to commit it with an informative message, create list of snacks. And then I'm going to push it to GitHub. So I'm going to git push. Where I'm going to push it is to origin, which again was just the short form for the name of that URL that we set. And what I'm going to push is all the changes I've committed on the main branch. Okay, so again, raise your hand when you're done so I know people have got it. Sorry if you raise your hand and then it disappeared. I think it disappears after a certain amount of time. And if I go to my GitHub now and I refresh, why isn't it working? Now I see snacks. Sorry, when I did refresh before, I think I was still viewing my repository at a certain point in history when I hadn't made snacks yet. So I had to actually go back to the main folder. Now I see snacks. Yay, with popcorn and candy. Okay, so I'm going to move on just because of time, but if you're still stuck and we have time near the end, we can try to address what you're stuck on. So yeah, you all get a cookie. So now I'll just briefly touch on what you can keep learning and how to keep learning. So again, what we've covered today is kind of like the basic commands that you need if you're working by yourself. You're just making changes and recording the changes and pushing them to GitHub. But there's so much more. So we've covered basically up to this purple. Here, I'll make that full screen. Purple, we did initialize. We made a change, added, committed, pushed it to GitHub. We looked at the status. We looked at the difference between different parts of our tree or different commits. And now another thing you can do with GitHub is you can actually first create a repository on GitHub and then clone it to your computer. So that's another way to start a repository instead of doing git init. And then you can also make changes on your remote Git repo and then pull them to your local repo. And another level of GitHub, which makes actually GitHub a really useful tool, is for collaborating. I think that's actually one of the purposes, one of the reasons why people made Git and GitHub. Correct me if I'm wrong, any of the panelists. So say I want to contribute to a big open source repository, I can fork it to my own repository, which is basically just like making a copy on my own repository. So I can do changes there without like messing up the main repository, and probably I wouldn't have permission to change the main repository anyways. So I'd fork it to my repository, my remote GitHub account, and then I would clone that remote repository to my workspace. I could do changes, I could push to my remote repository, and then I could make a pull request, which is basically saying, hey, maintainers of this repository, do you want to add my changes to your repository? And another really useful part of Git, which is maybe the next thing that you could look at if you're just working by yourself, is how to actually undo changes. So say you want to go back to a commit like 3 commits before. So if you do reset, you're going to be losing your work. You can also use a command called checkout, where you're just kind of like checking out what the repository looked at that point, and you can do edits without erasing all the history. And then there's branches, which I'll just explain really briefly. So if you're working on your own, you could have like the main branch, you could have a different branch for adding documentation, you could have a different branch for adding a pre-processing step. But like I said before, you can really work with Git on your own and just on the same branch for quite a while. I started using branches on my own when I knew, soon I want to be collaborating on GitHub, and then I know I need to use branches, so I'm going to get used to using branches by myself. So collaborating with someone, it could be like, this is the main branch. This could be your work. This could be someone else's work. And each of these dots is a commit. So you can see you made 2 commits. Someone else made 3 commits. And then the line going back to the main branch is just showing that we're merging that work back into the main branch. Okay, Jerome just clarified checkout and reset. So checkout and reset do different things. Reset changes where the branch points to. Checkout changes what snapshot is currently sitting in your directory. Yeah, so that's a good distinction. Yeah, so correct me if I'm wrong, Jerome, but from what I understand, reset is actually like more permanent, where you could go back to, say, this commit, and you're essentially deleting what happened in these commits. Whereas if you do checkout, you could check out the repository here, kind of like how we clicked at those angle brackets, and then continue working from there. Reset, unlike most Git commands, actually has the power to delete part of the history. Yeah, so be careful doing reset. And again, I don't remember all these things offhand. Jerome's been using it more than me, so he remembers more. But if I ever want to go back a commit, I almost always look it up to make sure I'm not permanently deleting something. So coming back to the buffet analogy that I used for open science, you can think of Git also as a buffet. And we covered all of these commands on the top, but there's a lot more you can do. The important thing is, like, don't take away from this table more than you can handle at once. So really, if you just use git add and git commit, you can do a lot of your own work and keep track of it effectively. And then, once you're ready to share, you can use git push and git diff and git status just to kind of explore what's going on. But really, you only need git add and git commit if you want to keep track of your own work. And then come back to the table when you feel like you can do more. So Git is hard, not going to lie. I went through part of this tutorial on software carpentry, and again, I'll share the link. So I've done these highlighted sections, but there's a lot more that you can learn. And don't expect to remember everything. So like I just said, I always look up how to undo the last commit, so I don't reset things that I don't delete things I don't want to. Sometimes you want to actually delete things. Sometimes you just want to go back to a previous commit and continue working from there, but not undo the later commits. So yeah, Google is your friend. And something I did at the beginning is I actually just put a physical sticky note on my computer with the really common commands so that I didn't have to always be switching between windows on my computer to remember all these commands. And yeah, to learn it, you need to commit to doing it. I always laugh at my own puns, but no one else seems to think they're funny. So yeah, you need to commit to doing it for a while, and then you'll be able to understand it. So now I'm going to have a quick poll just to see. Oh, sorry, I forgot to stop sharing the results of the previous poll. I just want you to say how much you think you could follow of this tutorial, just so I can get a feeling for whether the pace was good and whether the content was good and so on. And we're basically done. So once you've answered that, if you have any questions, put them in the Q&A or in the chat. I won't be asking for any more things typed in the chat, so that's fine. And if you were still stuck, say, making that snacks.md file, we can help with that. So some people have their hands raised. Is that for a question, or maybe you forgot to lower your hand earlier? But okay, 3 people, 1. Okay. Yeah, it's really good to have a refresher on these things. Honestly, it's not really, we don't expect you to come to 1 2-hour tutorial and be able to use it every day. Like you have to, if you want to use it and you're convinced it's a good thing, you have to try to incorporate it into your work every day, and eventually it'll become second nature.
Yeah, maybe just one word on this. I think it's an investment that you're doing if you're trying to use Git, but you have to believe those who have used Git for a long time for doing their research, and trust them that this is a worthwhile investment for the future. So it's not an easy kind of like a quick thing you can use very. Like in a GUI, it's not that easy, but it's actually a very good model behind the scene, and it's a very good practice for reproducible science. So just a little word of encouragement and motivation. Keep up with it and stick with it, and you'll be rewarded for sure.
Yeah. You could think of it as like, say you already know how to write like on paper, and someone's like, you should learn how to type on a keyboard, and you're like, why would I learn to do that? I already can do this writing, and it's going to take so long to learn how to type. But once you know how to use computers, it like vastly changes how efficient your work can be and what you can do. There was a question and it's disappeared, so I don't know if somebody answered it by typing the answer, but it was about like, can we use Git to track, say, Python files? And the answer is yes. That's probably, you wouldn't usually just be tracking like a list of desserts. So that is much more, a much more realistic use case actually. And, I don't know if, maybe Lex or Jerome wants to turn on their mic and explain like why Git works to track like a Python or a text file or a markdown file, but not like a Word document.
Sure. So basically all code that you write is a text file. So basically the only difference between a text file and a code file is what is interpreting the file. So for Python, for example, you're just going to have a bunch of code, which in itself is just text, but you put it through a Python interpreter and then it's going to run. Now, a Word file is basically a zip file containing a bunch of formatting and then some MXL. What that means, don't worry about it. But the actual data which is being stored is not neatly separated by new line, which is what Git uses to separate between changes. So if you modify one character in a Word document, the entire thing is going to change. So it'll look as though you just modified the entire docx file, but it's not going to list out the individual changes that you made. And that basically applies to all code, not just Python. And that's one of the reasons why Git is so commonly used in coding.
Yeah, and I think that's, it gets more and more important as you do more complicated things. Like if you're collaborating and say you do a pull request to a big open repository, if it's going to say you change the entire document when you just changed one letter, then it's going to be really hard for them to figure out what exactly you did. So this method of just recording line by line is like a good, efficient method of, an intuitive method of being able to see, just looking at a document, what's changed and whether you want to keep the changes or ignore them. Yeah, and that's a good point that I didn't mention. Someone was saying you can use the .gitignore file to make Git ignore files. So say I have like a huge data file in this folder. I could ignore it by typing the name of the folder, say it's like data, in the .gitignore file, and then Git's not going to track it. And one of the reasons for that is that you can't, there's a size limit to how much you can track on GitHub. So you can't put your like 1 terabyte neuroimaging data set on GitHub, but you could put your code. So either put the data in an entirely different folder, or make sure you have it in a gitignore file. And that's something that's covered in that tutorial that I mentioned. This one, the software carpentry tutorial. And I'll put the link in Slack so it's not lost when we exit this presentation. So
there's another question which came up yesterday about password access, specifically on GitHub.
Yeah. Yeah, so someone is saying you just received an email that says you recently used a password to access the repository of Xdesserts with Git using git/the version number. Basic authentication using a password into Git is depreciated and will no longer work soon. Yeah, sorry. So since I made this tutorial, I guess Git has changed, and probably in the setup section, it needs to be set up differently.
Yes, if you go to your account settings, there'll be a section on SSH and I forget the other one, basically keys that you can set up. And
okay.
That's a more secure way of getting into GitHub.
Yeah. I'm curious if software, so I use the setup instructions from the software carpentry tutorial, so I'm curious if they changed. Well, that's not very helpful. Now it looks the same, so I guess they haven't updated it yet.
Yeah, so that basically applies to GitHub and GitHub exclusively. If you're just setting up Git repos on your local machine, you basically don't really have to worry about that.
Okay.